Hello, my wonderful students, for a short but good physics session. I hope you have your handwritten ramp sheet from class, the one I made for you. If not, there are copies that have already been uploaded to the wiki page. Please have it out. You're going to be learning a lot with me about it in a short amount of time. So today's topic is to be a complex look at forces and inertia from a single example before we start our fourth topic, which will be momentum and impulse. This is also going to deal with some of the misconceptions you might have had about forces they don't exactly know about yet that can leave you confused. So what I want you to do, if you don't mind, is quickly just like pause this video and read over the opening paragraph and the two student statements. I'm waiting. You're doing this. And you are back. So the whole point of this is students are arguing, does the mass play a difference in the force required? You should have now write down, if you haven't done it already, what parts of student 1's stuff is correct? What part is incorrect? Same as student 2. What parts are correct or incorrect? And the major question we're also going to answer is, does the block's mass have an effect? We're going to prove if it does or does not. So you're pushing the ramp, which is going to move, and you want to make it so that the mass on the ramp does not move up or down. Student 1 says, both masses matter. The force you push will make the ramp move. True. Which will cause a reaction force by Newton's third law in the block. Also true. The ramp is moving into the block, which means that the block is going to be pushed to the right, which means there's going to be opposite force of the block onto the ramp left. The force of the block on the ramp involves its mass, which affects the acceleration. True. Student 2. The force you push will accelerate the ramp due to Newton's second law, which results in a force. Correct. That force is perpendicular to the ramp and plays no role. Incorrect. This question is trying to get to your point of what's a normal force versus a regular force. The ramp is going to be moving right. Therefore, it's going to be pushing the block also right, which means that the block is going to push the ramp left. It's not a normal force because the mass of the ramp is moving. Normal forces are when the surface is still. So the entire second question is predicated on you saying, oh, there's a block on a ramp, there must be normal force perpendicular. But the ramp is physically moving, and it's going to push the block to the right. So here's my statement, the truth and falsehoods, as you see right here. So who is right? We're going to say student 1 is right. And we're going to prove it together as well as my previous statement. Here's what I want you to think about it. I'm going to show person A is correct. Here's my cute little picture. You're pushing to the right. We have purple mass for the ramp, little green mass for it. The major idea I'm going to get to you is, it's like I'm pushing both things combined. And since there's an imbalance, it's like I'm pushing both masses with some acceleration. Major points that we're going to see. If I apply a force to the ramp goes right, and it also applies its own force to the block. But the force of the ramp on the block is not the same as the force of me pushing on the ramp, because the inertias are different. So if I push 100 newtons on the ramp is not going to push 100 newtons on the block. It's to be very different because of different masses involved. Take a look at the picture I made. Here we go. I'm pushing to the right on the ramp. The ramp is going to make its own force on the block also to the right. By Newton's third law, the block is going to have an equal force to this on the ramp to the left. So if I push 100 newtons, the force of the ramp on the block is going to be much less. Let's say 40, which means the opposite force of 40 as well. It can't be the same force because that force is being distributed among both masses. Now the real key point, in order for the block not to move uphill or downhill, the acceleration of the mass and the block, let's try that again, the acceleration of the ramp and the block must be the same. Or else, if they're not the same, the block will move relative to the ramp. Long story short, if the ramp has got more acceleration than the block, that means the ramp will be going faster, which means the block is kind of like moving up the ramp. Because the ramp is moving faster, it has more acceleration, it will kind of outrace the little block. if the ramp has less acceleration than the block will be moving downhill because it'll be moving more to the right than the block, which means it'll slide down, down, down. So in order to keep it in place, the accelerations must be the same. So at this point, to prove this original statement, let's go to the free body diagram. The ramp has got two forces on it, my push to the right and the block's opposite push left. It's creating an imbalance, which is the mass's ramp times acceleration. On the little block, it only has one force on it. Ignoring weight and gravity, but it doesn't really matter because weight and gravity is not really going to be a major difference in its acceleration. The force of the ramp is like the mass times acceleration. We can just assume it's an imbalance this way. But wait, you said weight before, but weight is going straight down. And since they're both accelerating to the right, it's not going to move downhill because of it. So I don't care about that y force with this x force. So at this point, this force on the block is equal to this force of the ramp. I could plug in MA for this force, and I could solve, and I find out that this is the general statement. The masses do matter, which makes a heck of a lot of sense. The more mass of the block, the more I need to push to make them both accelerate the same. And with that, my wonderful students, you just demonstrated how ramps work without them being still. As you're going to see, you could actually have things moving like the ramp and do some good calculations, or even better, some general approximations of what's going on. I want you to check your homework, and I want you to come in ready with questions and statements as you finish up this force stuff the next day, and we start going into the really cool stuff of collisions and impacts and impulse. Take care, my friendlies.